In this segment, we will be looking at more math functions. In particular, we will be learning some of the statistical functions that you can apply with the MATLAB. So let's define a matrix containing some values. It's a 3 cross 3 matrix containing numeric values in this case. To find out the minimum value within this matrix, we need to use the min function. So by default, if you don't mention any additional arguments to this function, then it is going to calculate the minimum across the columns of this matrix. In this case, it will return a matrix containing a single row, which is also called a row vector. The minimum of this column was 1, and the minimum of this column is 2, and so on. If we want to compute the minimum across the rows, one way of doing it is by taking the transpose of the original matrix and then use the function min. The minimum of the first row was 5, for the second row it is 7, and for the third it is 1. Another way of doing the same is by specifying additional arguments to the function. First, we specify empty square brackets and then the dimensions across which we want to perform this function. By default, it has a value of 1. And if you want to calculate minimum based on the rows, then you will mention 2 over here. Now it will compute the minimum across the rows, and with 1 it is performing the operation on column wise. So we can also obtain the indexes of the minimum values. By that we mean the location in the matrix that corresponds to the computed minimum values. We can obtain the indexes by specifying additional 2 output arguments in the square brackets. The first argument will hold the minimum values, and the second argument will hold the corresponding indexes of those minimum values. These are the 2 outputs that we were expecting from this particular function. Right, so it says that in the first column the minimum values is 1, and you can find this value at the third location within this particular column. Let us display the matrix A again for a clear look. We note now that the minimum value is 1 and it is at index number 3 within the first column. Similarly, for the second column, the minimum value is 2 and it is at index number 3 in the second column, and similarly for the third column as well. We can always do the very same operation on the rows by mentioning the additional arguments. In this case, it is giving us the minimum values across the rows. For the first row, the minimum value is 5, which is at index number 1. Similarly, the second row, the minimum value is 7, and it is the second value in that row. And similarly for the third row. Similar to the minimum function is the maximum function, and the function name is max. When you pass to it a particular matrix, it will return the minimum values across the columns by default. If we are interested in computing the maximum across the rows, you can do it like this. And you can also obtain the indexes corresponding to the maximum values across the columns in the same way as we obtained it with the minimum function. The matrix I contains the indexes and the matrix M gives us the maximum values across the columns. At index 2 in column 1, we have the maximum value, which is 8 in this case. We can display the contents of the matrix A for a better look. The maximum value in the first column is 8, and it is the second value in that particular column. Similarly, we can do it for the rows by either taking the transpose of the matrix or by specifying additional arguments. Another statistical function which works in the very same manner is the mean function, which is used to compute the average across some values. When we pass to it a matrix, it is going to compute the mean across the columns. If we are interested in the mean across the rows, we can either take the transpose of the matrix or provide to it the additional arguments, and it will do the same job. Please note that in this case, we do not need to mention the square brackets. Okay, now let's learn some more math operations. The variance in the data can be computed by the function var or variance. By default, again, it is going to compute it based on the columns. If we pass to it a matrix with one row or one column, then it will return a single value. And again, as usual, if you want to perform it on rows, you either take the transpose of the matrix or provide to it the additional arguments. The additional arguments in this case is a little bit changed. For the third argument, there is no change, and you can either mention 1 or 2 depending on whether you want the operation on the rows or on the columns. The 0 in the second argument is the normalizing factor used to compute the variance. When you specify it to be 0, then in the formula a dividing factor of n minus 1 is used. And when you specify it to be 1, then the dividing factor is n. And n means the total number of observations in the data. For more details on this, you can always consult the official documentation page. So here we go. This W is the normalizing factor that we were talking about, which specifies the normalizing factor, and this is the corresponding description of that. So I would strongly recommend that you go through all these functions and try to practice them with their different variants and try to familiarize yourself with them. Similar to the var or variance function is the standard deviation function, which is used to compute the standard deviation, which works the very same way as the other functions we mentioned. For the row-wise standard deviation, we should either take the transpose or mention the additional arguments. Another function which you may use quite frequently is the sum function. When we pass to it a certain matrix, it is going to compute the sum across the columns. And if you want to perform the row-wise sum, then you can do it in one of the two ways. You can also compute the median, which is the center value after the values are being sorted in ascending order. The function we need to use is the median, M-E-D-I-A-N. By default, it is going to return the median values in the columns. And as usual, by taking the transpose, we can compute the row-wise median, or alternatively, we can mention some additional arguments. Another very useful statistical function is the percentile. So the percentile is a little bit different than the functions we have covered so far. In order to compute the percentile, we need to mention a particular matrix along with the percentiles that we want to calculate. For example, if we are interested in the 25th percentile, so it will compute the 25th percentile values across the columns. So for the first column, the 25th percentile value is 2.0. Alternatively, if we are interested in more than one percentile, for example, I am interested in 25th and 42nd percentile values. So now in this case, it will create more rows, each one for each percentile value that we have specified, and again by default it is operating on the columns. This means that for the first column, the 25th percentile is equal to a value of 2.0, and the 42nd percentile is equal to this value. We can always perform the percentile on the rows with the help of an additional argument, which is 2. So it is now calculating the 25th and 42nd percentile values for the individual rows respectively. So that was an introduction to some of the very basic statistical functions that you can use in MATLAB. An alternate way of accessing these statistics is over here in the workspace. In the workspace, you can access the maximum, minimum, mode, median, range, and other statistical functions. Finally, let us also mention the mode function. We need to call the function MODE and pass to it a particular matrix. It will return the value that is most frequently occurring in the matrix. Okay, one important note that you should be aware of, and that is if you are working with a two-dimensional matrix, such as this one, and you apply some statistical operator such as the minimum twice, then it will return a single value. And this is because when we first apply it, it is going to compute the column-wise minimum, and then we apply it again. It will be applied on the column-wise minimum values and will return the minimum value based on the single dimension matrix. That value is going to be the minimum in the entire matrix. the value 1 is the minimum in the entire matrix in this particular case. So that was it for this particular segment. We have introduced some basic statistical functions. In the upcoming tutorials, we are going to cover more interesting math functions. Do come back to cover that, and until then, enjoy math.